Hi, my name is Rachel. Welcome to this journey into the world of blockchain. Today, we're studying the chapter Scalability and Layer 2 Solutions. We'll see why blockchains need to scale, what Layer 2s are, and how they work. By the end, you'll know about rollups, proofs, sequencers, sharding, and modular design. Let's begin our adventure into making blockchains faster and more powerful. Why scalability matters. Blockchains like Bitcoin and Ethereum are secure but process very few transactions per second. If everyone tried to use Ethereum at once, it would slow down and fees would rise. This problem is called the scalability problem. To solve it, we need more speed and capacity without losing security or decentralization. That's where Layer 2 solutions come in. What is a Layer 2? L2. Layer 2 is like an extra highway built on top of the main blockchain. The base chain, Layer 1, is slow but secure. It's the foundation. Layer 2 handles transactions faster, then reports back to Layer 1. This way, we keep security while gaining speed. It's like having a fast train connected to the main station. Fundamentals of scaling means handling more transactions per second. One method is to make the base chain faster, called Layer 1 scaling. The other is to add layers above it, called Layer 2 scaling. Layer 1 changes are risky since they alter the core system. Layer 2 is more flexible, so most projects prefer this approach. Optimistic rollups. Optimistic rollups are popular Layer 2 systems. They group many transactions off-chain, then send them to Ethereum in bundles. By default, they're assumed correct. That's the optimistic part. If someone suspects an error, they can challenge it using a fraud proof. This makes transactions cheaper and faster while staying safe. ZK rollups work differently. They use zero-knowledge proofs to show transactions are valid. The proof confirms correctness without revealing all details. It's like showing a certificate proving your math homework is right without every step. ZK rollups are efficient but harder for developers to build. Fraud proofs. Fraud proofs are used in optimistic rollups. If a bundled transaction seems wrong, someone can submit a fraud proof. The system checks it, and if fraud is found, the bad transaction is rejected. It's like referees checking a replay after a foul. Fraud proofs keep the system honest without checking everything up front. Validity proofs. Validity proofs are used in ZK rollups. Here, the proof is built in from the start, so no challenge is needed. This guarantees transactions are valid before reaching the main chain. It's like handing in a signed certificate that instantly proves your marks. This makes ZK rollups secure and quick to finalize. Sequencers. Sequencers are like traffic controllers for rollups. They decide the order of transactions and package them into batches. Without them, transactions could be messy or delayed. Of course, sequencers can misbehave, but better designs are coming. In short, sequencers keep the Layer 2 highway smooth. Transaction ordering decides who benefits and who pays what. If two people want the same NFT, the order decides the winner. Bad actors may reorder transactions for profit, called MEV, maximum extractable value. Layer 2 systems try to keep ordering fair and transparent. It's like keeping a proper queue at a store. Plasma was one of the first Layer 2 designs. It creates mini blockchains linked to Ethereum. Most work happens off-chain and only summaries go to Ethereum. If something goes wrong, users can safely exit back to the main chain. Plasma is less common today, but inspired modern solutions. Sidechains. Sidechains are separate blockchains connected to the main chain. They run in parallel and let assets move between them. Unlike rollups, sidechains have their own security, not Ethereum's. This makes them faster, but sometimes less safe. They're like nearby towns connected by a bridge. Cross-rollup communication. As more rollups appear, they must talk to each other. Cross-rollup communication allows assets to move between them smoothly. Without it, users would feel trapped in one rollup. Developers are building bridges and standards to solve this. The goal is a seamless experience across rollups. Sharding basics. Sharding scales blockchains at layer 1. It splits the chain into smaller shards, each processing part of the load. This way, nodes don't handle everything. It's like dividing a big classroom into smaller groups, each with its own teacher. Ethereum plans to use sharding to support Layer 2 growth. Modular blockchain design. A modular blockchain separates its responsibilities. Execution handles transactions, data availability stores information, and consensus ensures agreement. This makes blockchains flexible and easier to upgrade. Rollups focus on execution, while Ethereum secures data and consensus. It's like dividing chores in a house. One cooks, one cleans, one pays bills. Rollup-centric Ethereum roadmap. Ethereum's future is focused on rollups. Instead of making Layer 1 super fast, Ethereum will act as a secure base. Rollups will handle most user activity, while Ethereum ensures trust. This vision is called the Rollup-centric roadmap. It's a step towards scaling Ethereum for millions of users. Comparing Layer 2 types. Each Layer 2 has strengths and weaknesses. Optimistic rollups are easier but slower to finalize. ZK rollups are faster and safer but harder to build. Sidechains are flexible but depend on their own security. Plasma was early but is less used today. In the end, many solutions will coexist. Benefits of Layer 2. Solutions? Layer 2s bring big advantages. They lower fees, increase speed, and make apps smoother to use. This unlocks industries like gaming, payments, and finance. Users get cheaper, faster transactions, and developers can build apps once thought impossible. Overall, Layer 2 makes blockchain practical for daily life. Challenges. Ahead, challenges still remain. Rollups need better communication. Sequencers must become more decentralized and fair. Bridges between chains must be secured to stop hacks. These problems aren't simple, but progress is fast. The future of scalability looks bright. Conclusion. We've now explored scalability and Layer 2 solutions. From optimistic and ZK rollups to sharding and modular design, you've learned the key ideas shaping blockchain's future. Ethereum is moving toward a rollup-centric model, where Layer 2s act like highways for millions of transactions. Thank you for joining me. The journey of scaling blockchains has only just begun.